Hi, this is my retro gaming PC that I built from an old x86 based firewall. It didn't come with hard drive connectivity or most importantly video output. I'm going to walk through how I managed to make those upgrades to this machine. If you wanna know how, please stick around. My main goal is to give some ideas on how old x86 based PCs or firewalls like these can be modified and reused. I believe sharing know-how or open source project like this will help reduce electronic waste and support the SDGs. These are the subjects that I will be covering on this video. First, I'll make some hardware upgrades and then I'll test some DOS games on FreeDOS. I got this penless 886 firewall from an online auction for about $8. Since it's a legacy device, I couldn't find anything useful. Well, there is no display output. Let's take a look inside. While handling motherboards, use proper ESD protection. Make sure you ground yourself before touching anything. Here is what I found after searching for SMD part markings. There were some unpopulated components on each side of the board. Let's take a look at the other side of the board. Let's focus on the video output. Since I couldn't see any video related chips, I checked the SoC's datasheet for integrated graphics. And bingo! SoC has integrated graphics that support VGA, DisplayPort and HDMI. Then I checked the pin count of each of them. Actually, there is an unpopulated connector with 19 pin pads on the motherboard. As we know, high-speed differential signal pair traces must be close together on the PCB. There are 4 of them routed to this connector from the SoC. Then I checked those 4 differential signal pairs to see if they match the HDMI pinout. Well, this is exactly what I was looking for. Since I can't see any unpopulated SMD parts, I will give it a try. First, I tried to fit a cheap HDMI connector by bending the pins. That's such an art. Then I soldered the HDMI connector and connected to the monitor to test it. After trying out, it didn't work. Graphics may have been disabled. To check this, we need to enter the BIOS. There is a feature called Serial Port Console Redirection that allows the BIOS to be configured from the serial port on servers or embedded devices like this. Well, we need to find the serial port which wasn't exposed. What I am going to do is set up the scope with the known source, touch the pins on the board and check if I can get a signal. I am going to start with the unused connector here. Here we go. Touch the pin, turn on the PC, check the scope and turn off the PC. Next pin. Touch the pin, turn on the PC, check the scope. Well, we found it. So how about RX pin? The TX pin is connected to this IC. Probably the RX pin is connected to this one. Then I soldered some wires and connected to the PC via the USB serial converter. Then I opened the VT100 terminal, turned on the device and tried to enter the BIOS. Well, this is not my lucky day. The password is likely hard-coded in the BIOS ROM and possibly stored in the SPI flash here. I simply remove the SPI flash and read it with my fancy programmer. Then I open the BIOS ROM file in this open source tool and try to find the supervisor password. Well, it was pretty easy actually. I put back the SPI flash and retry to enter the BIOS with the password that I found. Voila! After entering the BIOS, the first thing that I checked was whether the graphics was enabled or not. Well, it was disabled. I enabled the integrated graphics and saved the settings. I connected the HDMI cable and powered up the device. Look at that! After using it for a while, I found out these BIOS settings work better. Well, as you have guessed, the HDMI connector didn't last long. Meanwhile, I found an ideal match for the HDMI connector and replaced the old one. Then I cleaned with the IPA. This is the front panel of the firewall. To access the HDMI port, I need to cut the panel. First, I marked the panel and visited the machine shop. This is the milling machine that I'm going to use. Then I set the vise using the dial indicator. To avoid any scratches, I use masking tape and set the panel on the vise. Always wear protective eyewear when operating or in proximity to the milling machine. Next, I set the end mill in the drill chuck. Then I finally started milling operation. Since the material is little sticky, I took low depth multi-passes to get a better finish. This is how the panel looks after the milling. And this is what it looks like when mounted back. Even though it already has an eMMC, we can use it as a standard computer by adding hard drive connectivity. When I was checking the motherboard, I noticed that the unpopulated connectors here looked like SATA ports. Suspicion faded away after seeing the SATA controller enabled by default in the BIOS. So let's try to get it working. We have two similar patterns. Let's focus on one. After measuring these voltages, I knew this was a power connector of the hard drive. The circuit diagram looks like this. Let's tweak the layout. This is actually a second stage filter to reduce output noise. This design guide explains how to determine the capacitor and inductor values. I soldered some capacitors and shorted the inductor pads, which I didn't have at the time. In the end, I could measure the voltages expected at the power connector. Well, what else? There are two pairs of unmounted caps on the data lines. Since the SATA specification is not free, I looked for SATA interface circuit diagrams on the web and decided to use 10 nano. Then I soldered the caps as well as the SATA port. Next, I connected an SSD drive with SATA cables. Then I turned on the machine and checked the BIOS. It was recognized on first try. To fit everything into the enclosure, I bought a short cable. Then I cut the power connector and replaced it with the matching one. Next, I connected the SSD using the new cable. Now the SATA port works, but there is a small problem. There is no place to mount the SSD, so I need to make one. I was going to use my DIY 3D printer, but since I wanted to improve my metal forming skills, I will go with that. This is where I want to place the SSD. Since the SSD is not heavy at all, I am planning to make a bracket that goes on top of these threaded inserts and this aluminum sheet salvaged from an old laptop housing case. Then I took some measurements for the template. After making the template, I placed it on the motherboard and check if it fits. Then I stuck the template on the aluminum plate and cut it out. Next, I center punched the hole locations, then I drilled the mounting holes using a pin vise. Then I made the legs by bending them with flat nose pliers and removed the template. To increase structural rigidity, I bent the bracket edges. Next, I scraped the PCB and removed the solder mask. Then I soldered the threaded inserts to the motherboard. Next, I center punched the hole locations, then I drilled the mounting holes using a pin vise. After enlarging holes and some filing, I used polyimide adhesive tape to provide electrical insulation. Then I installed the enforced screws and nuts that will hold the SATA connector. Next, I fixed the mounting plate on the top of the threaded inserts. Then I connected the SATA cable and fixed it. And finally, I plugged the SSD. It perfectly fits into the enclosure. I think there is enough clearance between the case cover and the SSD. And finally, I put everything together. First, front panel screws. Then bottom panel screws. SATA and HDMI upgrades are done. Everything fits into the enclosure. Isn't that beautiful? There you are, I gotcha! I've created a bootable USB installer for the full version of FreeDOS 1.3, which also comes with a few free games. Installation is straightforward. It asks you a few questions and before you know it, it's over. Let's play some games, shall we? First, I will go with the Prince of Persia. The PC speaker is quite powerful. I don't know how you play it, but I was playing with the PC speaker at the time. If you know how to fix those glitches, please let me know in the comments. Wolfenstein 3D. This is another game that I was playing with the PC speaker at the time. Duke Nukem 3D. This is my favorite first-person shooter game. And it looks amazing. Yeah, I don't use a mouse. I never get used to it. This is one of the games that absolutely needs to be played with a sound card. Alright, I need a sound card. I hear you, and in the next episode I'm going to make a sound card and fit into the enclosure. Please consider supporting my work on GitHub, Patreon and Ko-fi. You can find me on social media and see sneak peeks of projects that I'm working on. If you found this video informative or helpful, please click like. And if you want to see more, please subscribe to help me grow my channel. Let me know what you think in comments and let me see how much interest there is in these videos. Thanks for watching.